Good morning. Welcome. My name is Vic Nagji. I've met some of you over the past few years. Looking forward to meeting the rest of you later today, throughout the day. I'm product manager for database platforms. And today I would like to take a little bit of time to talk to you about two topics, even though it says three topics up there, two main topics. The first one is around big data, and the second one is around cloud. So we'll start today with big data. And a few years back, Gartner coined what's now the famous 3 V's of big data. So let's take a look at what the 3 V's are and what they mean. If you will notice, I have what's big about big data up there, and the big is in parentheses. And the reason why I put this in parentheses is because I think that these 3 V's apply to all data, not just big data. So let's take a look. The first one is variety. This is all about the different types of data that exist today. Structured data that fits nicely in databases, unstructured data, textual data, social media, blobs, etc. Movies, images, those sorts of things. So there's a lot of variety of data. The next one is velocity, which is essentially how quickly this data is arriving. Steve mentioned in his presentation connected systems, mobile devices, and just devices generating a lot of data. So data is coming in at a very, very fast pace. And the third one is volume. There's a lot of data. So Gartner's whole idea about the 3 V's was to suggest that in order to qualify as a big data problem, you would have to be on the outer edges of these circles. And as these circles get bigger, you increase in your data volume, in your variety, the complexity of the variety, and your velocity. Now, while Gartner might be right around big data being classified as being on the outer edges of these circles, I really believe that it doesn't matter where you fit in these circles. You still have to deal with your data. So instead of thinking about this as a big data problem, we can think about this as a data problem. And based on that, I propose a fourth dimension of big data, or data. And I really think this is the real challenge. So we looked at the volume, we looked at the variety, we looked at the velocity. And I think right in the middle of all of those 3 things is our fourth V, or our fourth dimension, is value. How do we take all of the data that we have? How do we take all of the information that's coming in, unlock and generate value from that, and provide that value to our customers? I think that's really the big challenge around big data. Robert mentioned in his slide around Cache being a data platform to provide to you the base to be able to unlock value from your data by using your breakthrough applications. So I propose, along those lines, an image that depicts how you can use Cache as a data platform to unlock that value and generate value with what I call just-in-time action. And just-in-time action is basically about taking action and generating value at the right time. It could be by analyzing the data and understanding it. It could be by sharing the data with others and discussing it, etc. So as far as this journey goes, which is the big data journey, Starts with capturing. So bring in all of your data, store it, access it, aggregate it. And how is this different from a data warehouse? Robert also made a mention to, how our platform is different from what you would consider to be a traditional data warehouse platform. Well, in our platform, what you have the ability to do is you can do all of the analysis on your online transaction processing system, on your main system. You don't have to extract, transform, and load your data into a separate system, run your tests and run your queries there, and then realize that, oops, I forgot to extract some additional data that I need, so then go and run another ETL, bring it out, put it back in. You can just do all of this work on your main system. So capturing is about accessing and aggregating all of your data. Sharing is about connecting at an information level as opposed to connecting at a data level. So how can you make sense out of the data? How do you look at this data and get information from the data? Understanding, so this is where the analytics piece comes in. By using active analytics to gain insight from your data. And again, you can run all of the stuff on your single system. You don't have to have a separate data warehouse type approach. And I think this is the key. As you move through the capture, share, understand journey, you eventually end up with the opportunity to be able to act on that data. And acting on that data at the right time when it's needed. So you can drive and generate value with what I call just-in-time action. So tying it back to the famous 3 V's, we see that volume, velocity, and variety line up very nicely, and therefore we have our 4th dimension or 4th V of value along the act. And what I would like to do is I would like to spend a little bit of time talking to you about a case study that demonstrates all of the wonderful things about our platform, but specifically at the end, we will highlight and talk a little bit about how our platform provided the just-in-time capabilities for a very, very interesting mission. So some of you may be familiar with the European Space Agency's satellite called Gaia. And I talked a little bit about this, I believe, last year and possibly the year before that. I will talk about it every chance that I get because I am very much into astronomy and I very, very closely follow this project. So before we start about Gaia, this is a very beautiful picture that I would like to share with you. This was not taken by Gaia. This was taken in 1968. During the Apollo 8 mission. And the astronaut William Anders was taking photographs of the moon. So down here, this surface is the moon. He's taking photographs of the moon, and he looks up, and he looks to the right, and there's a window. And from the window, he sees the Earth. And he sees the Earth coming out of the shadow of the moon. So he took this picture. The name of this picture is Earth Rise, just like sunrise. Just wanted to share it with you. Has nothing to do with Gaia, but has a lot to do with astronomy. It's a famous picture. Okay, so let's talk about the Gaia satellite. The Gaia satellite is going to look at around 1 to 1.2 billion celestial objects, or stars, brown dwarfs, et cetera, over a period of 5 years. Over the course of its lifetime, it is expected to download down to Earth around 1 million gigabytes of data over a period of 5 years. And if you took all of that data and you put it onto DVDs, you would end up with around 220,000 DVDs. And if you sat down to watch these DVDs, it would take you 50 years to watch all of those DVDs. So that's a lot of data. For each star or celestial body, brown dwarf, what have you, that Gaia looks at, it's going to record various facts of this particular celestial body. It's going to record things like the position, the movement, the luminosity, etc. And what it's trying to do is it's trying to keep track of how these objects change over a period of 5 years. So it's going to take up to 70 to 80 snapshots of each object over a period of 5 years. As the objects pass through across its focal plane, it'll capture data about these objects, stored in the catalog on Earth. And we'll see why in a second. So it's going to see up to 40 million observations every day, which means that every day it's going to capture data about 40 million unique observations, and this results in around 285, 290 gigabytes of data created per day. And it's expected to discover many, many new celestial objects that we don't know anything about. Okay? And very proud to say that InterSystems Cache is the platform for the main pipeline for this project. And over the next few slides, I'm going to describe the significance of the Gaia project to civilization, to mankind. And then I'll talk a little bit about how Cache helps them be able to achieve what they want to achieve. And then we'll have an example of a real life case of just-in-time action. Okay, so to set this in context, frame it, the previous satellite that was out there that created a map was called Hipparchus. And Hipparchus was very, very, very good at the time, but it only was able to capture data for 120,000 objects. Compare that with the number that Gaia is going to capture, and you will see that it's many orders of magnitude larger. Also, what's interesting is that the accuracy of Hipparchus was very good at the time, but Gaia's accuracy is also orders of magnitude better, which allows Gaia to see much more distant objects, much fainter objects. Okay, so this is from the European Space Agency website. I'm not going to read out all of these words. All I'm going to do is point out one of the goals that I find very fascinating from this project. And that goal is to try to answer the formation history of our galaxy. Okay? By capturing all of this data and this much data, and over a period of 5 years, cataloging how these celestial bodies change, scientists are hoping to be able to rewind back in time to the formation of the galaxy and really see if what we know about the galaxy today is really true. Okay? This is going to happen in our lifetime. 5 years later, 5 years from now, this data will be all the data will be collected. Then there will be another 5 to 10 years of processing of the data. And then they'll build models. And then sometime in our lifetime, I expect to know whether this holds up or there's some changes to what we have known and learned over the years. Okay, so how does Cache fit in? So this is another diagram from the European Space Agency that describes the general flow of data from the satellite. The satellite is depicted on the top left-hand side in red. And you will notice that there's sort of a pipeline that's maintained for this data. At the heart of this pipeline is what they call the main database, or MDB. This is running Cache. Okay? I have also highlighted two other pieces that are critical and the initial points in the pipeline. These are all running Java applications which are served by the Cache database. So they use Java, and I'll describe that in a second. They use Java to access the data, straight JDBC, nothing fancy, and the Cache runtime engine provides them with the access to this data. So from a volumes perspective, there's again a lot of numbers up here. But the interesting thing here is that on a regular day, we expect to have around 285 gigabytes. So that's 285,000 megabytes of data generated. Normal scanning law says that there are some bands in the universe where the stars and celestial bodies are more dense. So there's going to be 3 to 5 days every year where Gaia is going to pass over these dense bands. And in those days, it's going to collect maybe 7 times more data. So you take the 285 gigabytes and you multiply it by 7. So the per day growth is expected to be 280 gigabytes. For the first 4 months, all of the data is kept. So it's around 34 terabytes. In the 5th month, there's some cleanup that occurs, and you end up with a 3 terabyte database, and that's what's maintained throughout from there. Okay, so we talked about all of these fascinating things. Now let's talk about the important stuff. What kind of hardware does it take for Gaia, for the European Space Agency to run the software for processing all this data from Gaia? Let's take a look. It takes one database server with a network attached storage, not fiber channel, of whose list price as of yesterday when I looked was around $200,000 US. That's for the server plus the storage. Okay? What else does it take? It takes an asynchronous disaster recovery system, which is a server and a storage, again, network attached, and NFS in this case, not even iSCSI. And list price for that as of yesterday was $90,000 for the server plus the storage. There are 20 application servers which are running their Java application. They connect to cache via JDBC. The list price for these is a little bit high because they have a lot of memory and they have a lot of CPU. But remember that this is their applications that are running in Java, right? So this is around $10,000 per server. So if you have 20 of those, that's $200,000. And they don't have any requirement for high availability because their SLAs are fairly relaxed because they can stop the system and restart it when needed. But they do have disaster recovery, and they use our database mirroring product for asynchronous replication. So putting that into context, you can map the entire galaxy for less than $500,000. And if you do the math, then per celestial object, the cost per celestial object is fairly low. But answering the formation history of the galaxy is, I think, priceless. So we have a very, very, very good use case here of how we are able to help somebody with some pretty extreme data requirements, velocity, variety, et cetera, and help them generate value. Okay? Now, let's go and look quickly at what we were able to do from a just-in-time standpoint and how they were able to leverage cache and the features to fix what was potentially a really big problem. So here's what happens. The reason for the pipeline is not to build the catalog. The catalog will be built after 5 years, after all the data has come in. The reason for the pipeline is to inspect the quality of the data that's coming in from the satellite. If there's a problem with the quality of the data, we want to know that now. And so we can fix it now. We don't want to get 5 years of bad data, at which point the satellite is done. It runs out of gas and it goes off into space debris. Instead, we want to know that now so that we can fix the satellite. When Gaia was launched, on its way to its orbit, to where it's stationary at the moment, it took a few test images. And it's not going to take too many images, but it took a few test images to make sure the sensors were working fine. This was the first test image from Gaia. In analyzing the data from this test image, these words are small, but I'll tell you what they mean. In analyzing the data from this test image, by using the main pipeline to ensure the quality, the scientists found that there was actually a problem with some of the sensors. There was space debris that had landed on some of these sensors as part of the deployment process. So they had to change the orbit of the satellite. They had to move it out a little bit further. They had to shake it a little bit. And it took several weeks for them to fix the problem. But they found it immediately. They found it just in time. They were able to fix the problem before it got into the state of actually starting to observe the data. It's just in time. Okay, so I'm going to end this really nice story with some pictures because everybody likes pictures. This is the Gaia satellite that's inside of the fairing before it was attached to the Soyuz rocket. This is Gaia taking off, attached as a payload to the Soyuz rocket. And people like pictures.
9, 8,
Videos are better.
7, 6, 5, 4, 3, 2, 1, top, décollage.
I watched this live on YouTube. They were broadcasting it. It was 3 o'clock in the morning, my time. I watched it live and I was very nervous. I wanted to make sure that the satellite didn't blow up trying to go up. And fortunately, everything was fine. So, in summary, the significance of the Gaia satellite to us is going to be quite similar, I think, to the significance of maps on the evolution of civilization. So maps help us so much today. So if you think back to when the maps were originally created, it allowed civilization to expand, it allowed us to explore new areas, grow, etc. And similarly, the Gaia project is going to help us understand and unravel the chemical and dynamical history and composition of our universe. For our galaxy. So that's a little bit about Gaia. Very happy to answer questions about it all day. Please come and find me. Very enthusiastic and happy about this project. Okay, how are we doing on time? Okay, yeah? Okay, so moving on to the next topic. 2 topics in one, 2 together. Okay, so cloud and virtualization. This infographic from Gartner was from 2010, which shows that virtualization really is the stepping stone and the base for the cloud, right? I mean, without virtualization, you don't get the cloud. Which is why I say, when I prepared this presentation, it occurred to me that it was probably best to talk about them both together because the value generated by virtualization or the cloud is the same. It's just different in terms of how you deploy or where you deploy. Now, for those of you who are interested in actual technical details about how to configure a VMware environment, for example, or a virtual environment, for example, what are the best practices? How do I configure for high availability? How do I configure for performance? We are preparing a white paper for that, which will be on our website. So you'll be able to get technical details on that as well from a virtualization standpoint. But from a business standpoint, I think if we come all the way back, they're the same thing. There's no difference between virtualization and cloud. So let's just talk about the cloud. Okay? So the National Institute of Standards and Technology defines the cloud with some nice words, but I think that the key words here are the ones that are highlighted. On-demand, shared pool, rapidly provisioned, minimal management. These are the key features of a cloud. Well, what do I think? I really think cloud and the value generated by the cloud or the business reason for the cloud is really about accelerating value delivery to customers. It's about you being able to accelerate value for your customers. And it's all about taking advantage of all of these advances in information technology so that you can accelerate the value delivery. So there are many different definitions and types of clouds out there. From my perspective, from a software standpoint, I think these 4 make sense. So public cloud, like Amazon EC2 or Microsoft Azure. You have a private cloud concept. Virtualization-based cloud where you buy the servers and you virtualize it and you create your own cloud. Or a SaaS offering. So a SaaS offering, software as a service offering, is also sort of a specific trend or specific type of cloud computing that I like to call out. And why do I do this? Let's look at a very, very complicated graph. It took me a long time to really understand what this means. So I'll explain it to you now. This is a graph from Gartner. This is called their hype cycle. And the whole goal for this hype cycle, so they take some key terms and they create a hype cycle from it. And what that means is all of the terms and trends associated with that key term, they plot those along this curve. And as you'll notice, all the way from the left-hand side, that's the innovation trigger. That's something that people just start talking about. And then this hype cycle goes up, and then it comes down into what's called a trough of disillusionment, which means that everything to the left of that failed. And then it goes back up and sort of plateaus out all the way into the plateau of productivity. Right before the plateau of productivity is this area called slope of enlightenment. And that's exactly where software as a service sits. And this was in 2013. In a few years, I fully predict that software as a service is going to be further out. So the purpose of this particular slide is to demonstrate that software as a service is viable. It's not a hype. It's here to stay. And it may make sense for your application to take advantage of the cloud. And if you do, great. There's business out there. What else does Gartner say? Gartner says that by the end of 2013, software as a service will be a $14.5 billion market. Billion dollar market. And in fact, if you read the finer print in their article, they say that by 2015, it will be up to $22 billion. So again, great indication that there is business out there. There are opportunities out there. Software as a service is a real thing. It's not a fad. Okay, so what's so interesting about the cloud, right? And software as a service in general? Well, it's about accelerating value delivery to your customers. And you can use the cloud to deploy your breakthrough applications quickly and generate value quickly for your clients. Some of the features or benefits of the cloud are listed here. You only pay what you need. You can have virtually infinite computing resources. The cloud is elastic. That's one of its key features. What does elastic mean? It's like a rubber band. You grow when you need to, and you shrink when you don't. So you increase your computing resources when you need it, and you decrease them when you don't. You can provision this on demand as and when you need, and you can stay lean and agile. You don't have to make a big capital investment for all of this infrastructure, and you can just pay for what you need. But I caution you, there are some things that you should really look at. And I don't expect you to read all of these words, but this was just an example from the Amazon EC2 website. All the other cloud service providers have something similar, but you really need to understand what this means. The service level agreements that Amazon offers is a guarantee that your system is going to be available 99.95% or better every month. So if you do the math, that works out to around 22 minutes of downtime per month. Okay, so if your system is down for 21 minutes in a given month, they are still within their service level agreements. So what does this mean? Can your application survive a 20-minute outage in a month? Maybe your application can, maybe it can't. I don't know. It all depends on your application. But point of this slide is you really need to understand what some of the challenges are in the cloud, and the service level agreements are one of them. But if you look further down into the fine print and ask the question, okay, what happens if for some reason the Amazon system is down for 26 minutes, right, which is greater than 22 minutes? What happens? Well, then you find some interesting stuff where they say that if our system availability is between 99.5% and 99%, which means my system is down anywhere from 22 minutes to 7.2 hours, I will give you some discount. And discounts are great, but discount doesn't mean that your application will be able to continue running. And discount probably doesn't mean that your customers are going to be happy, right? If your system is down, your system is down. So you have to understand these things and figure out whether these sorts of limitations are a challenge for your application. And there are ways around this. You can pick different regions to deploy your application in for a single cloud service provider. You can pick multiple cloud service providers. You have a lot of options, but try to go into it with your eyes open. What about some of the other considerations? So your application could be in a regulated industry where you have to meet certain standards. And the standards oftentimes extend onto the kinds of systems and servers that the application is deployed on. So if you are in one of those industries, it gets a little bit tricky to try to prove that a cloud service provider meets those needs. So you need to be careful. If you're in a regulated environment, you need to check to see that the cloud service provider can guarantee that they meet those needs. Cost. This is a very interesting one. There are a lot of hidden costs in the cloud. And what my recommendation is to everybody that looks at going to the cloud is to really do a lot of math and figure out ahead of time what the projected costs are going to be so that you don't have any surprises. Amazon, Rackspace, Microsoft, all of them have cloud calculators, cloud cost calculators on their website. And you can go on there and enter in a whole bunch of data based on what you expect your usage to be, and they will tell you what the estimated monthly cost is going to be. Okay. There's this thing called safe harbor, which basically some countries have, which say that if I have an application that's going to collect data for citizens in Japan, I must make sure that this data is stored in Japan. For example, my data cannot be stored for the citizens of Japan in the United States. I'm just giving you an example. There are some countries that have that, and there are some industries that require that. So if you have a safe harbor type application, or you have an application that has a requirement for actual location of data, the cloud may not be the answer for you, because when you put the data in the cloud, it's in the cloud. We don't know where it is, right? Could be anywhere. Okay. This is getting less and less of a problem because a lot of the big cloud service providers have gotten very good and very transparent about how they protect your data. But new cloud service providers come up quite regularly, and if you're going to pick a newer cloud service provider, you probably want to spend some time figuring out what their security is, what their encryption techniques are, how they have access control mechanisms, et cetera, et cetera. Okay. So finally, I'd like to leave you with some case studies. And these case studies are about what I consider to be really good examples of software as a service from our existing clients and existing partners. And as I was preparing these case studies, a thought occurred to me that we've spent 35 years really perfecting Cache from many different areas. So we keep improving our performance, we keep improving our scalability, we keep adding great new features, we keep improving our rapid application development environment. And we make all of these improvements. And as we did all of this over the last 35 years, we've ended up with a product, Cache Ensemble, however you want to consider it. We've ended up with a product which makes it so easy for somebody to just deploy in the cloud. You don't have to call us to ask us for a separate kit. You don't have to ask for a separate product. You don't have to ask for a separate license. It just works. You can take your breakthrough application, pop it into the cloud, off you go. And that's really what struck me as the simplicity of Cache, of the platform itself, on how easy it was for these partners of ours, which I'm going to describe in a second, to just leverage the benefits of the cloud. Okay, so You've probably heard of 3M Health Information Systems, and you probably will hear some more of that throughout the day today. But 3M Health Information Systems, so 3M is the company that makes the Post-its, you know, the Post-it notes. But they do a lot more than that. They actually have a health information system application. And what they wanted to do was they wanted to have some sort of enterprise service bus to orchestrate all of these systems inside of their health information system package. And they grew their health information system by acquiring other products. So you have a product over here for registration, you have a product over here for access controls, you have a product over here for bed management, so on and so forth. So you have, they have many different products that are part of the suite. And the way that they sell the suite to their clients is they go to a client, they say, okay, the base suite contains these 3 modules. And then if you want to add more modules later on, that's fine, you can add more modules. It's a modular system. It's a fully cloud-based system, and it's packaged up as a single health information system package. The challenge that they were having was they needed to have something very reliable to be able to orchestrate the messages between these components. So they were looking for a true enterprise service bus. So they picked Ensemble for that. And what's really neat about what they did was they created very, very quickly and easily with minimal interaction and help with us. We did talk to them and we did help them, but by no means was it excessive. They created a stateless, scalable, automatic cloud for the ESB. Basically, they have a system where let's say a particular health information system that's installed at a client, at a large client, has 3 enterprise service bus servers running in the cloud. And they detect automatically to know whether the overall capacity for these 3 systems is exceeding a certain threshold. Let's say that the CPU is 70% or higher now. Automatically, the infrastructure and the environment will launch another 1 or 2 enterprise service buses that are running, completely stateless, and add them on into the load balancer mix and automatically get messages. Then they'll notice, okay, when the system is a little less utilized, let's say overall system capacity is only being used at 20%. So they had 3 before, they added 2 more, they have 5 now, and they don't really need all these 5 running because remember, you're paying as you go. So the system will automatically do the reverse. Take 2 away, remove them from the load balancer, shut them off they go. So this is a great example of how easy it was for somebody to take Ensemble, the ESB functionality specifically, and leverage the cloud for it and really use it in a breakthrough fashion. Okay, Ontario Systems. This is a very interesting story. We actually have a case study of this on our website. Ontario Systems is a software company. It's an application partner based in the US. And they create receivables management software for third-party collection agencies. It's a very long sentence. So what does that mean? I'll give you an example. So I have a cell phone, right? And my cell phone provider is AT&T in the US, okay? Let's say I have an outstanding bill for $500 for my cell phone. And let's say I decide I don't want to pay them, okay? I say, sorry, I'm not going to pay you. So they'll call me, they'll send me a text message, they'll send me an email, they'll send me a letter. Please pay $500. They'll do that once, 2 times, 3 times. And eventually they'll say, you know what? We don't care about you. We're going to shut off your service. We don't care about your $500. We're going to take the $500 debt that you owe us, and we're going to go and sell it to this third-party collection agency who can then harass you all they want to get the money back. So this third-party collection agency would buy the $500 debt from AT&T for, let's say, $50. So they pay $50 to buy this $500 debt. Then they would come after me. And if I ended up paying them $100, they would make, they would double their money based on what they paid. They paid $50 for this $500 debt. I paid them $100. They just made $50, right? So these are third-party collection agencies. The government decided that the third-party collection agencies were going to be required to start keeping tracks of complaints. So if they called me and started harassing me and saying, you better pay, you're a bad person, I could say, I'm not a bad person, I just don't want to pay, right? And that's a complaint. So they are required by law now to keep track of this. So Ontario Systems very, very quickly realized that they needed to provide a complaint tracking application for their third-party collection agencies. And in the matter of 6 weeks, they were able to design, build, test, and deploy live in production a complaint tracking application. Now, that's an amazing example of rapid application development, and that's also an amazing example of how flexible this platform, our platform is, for our data platform is for people to be able to do such things. And not only did it ease the burden on their existing clients, but it also allowed Ontario to have a differentiator. So they went out and they said, hey, all you other third-party collection agencies who aren't our clients, look at what we have. And they got a whole bunch of new business there that way. So they use software as a service to solve a specific problem very, very quickly. And in the process, we're able to gain new business. It's a great, great use case. EventsForce. EventsForce is a company based in the UK. They provide end-to-end event planning and management software. So events such as this one require planning. It requires registration process, so you require a system to get registered, you require an agenda, et cetera, et cetera. So they provide software for events such as this. And they are a perfect fit for software as a service and deployment in a cloud model because each event is different. So if they go to an Apple event, they will have 5,000, 6,000 people at that event. If they go to another event, they might only have 20 people, 200 people. So the scale is very different depending on the environment that they're providing the software for. So they need to be able to have something very flexible that can be elastic and scale as needed. The other thing that differentiates them really well from other event management software is that their entire application is very modular, which means that let's say I set up the software for this event. And I said, I want attendees to be able to register. I want attendees to be able to pick the sessions that they want to attend. And I want the attendees to be able to see the agenda. Let's say I pick 3 different modules at the beginning. Now let's say we start this event this morning at 10 o'clock. And just before we started, I have a thought. I said, wow, maybe it would be really nice if the attendees could also use the online system to give feedback for the sessions. Okay? But the session's just starting. They have a modular system where it doesn't matter if you've already deployed their application for a particular event. Because of the modular nature, you can just go in and configure the new module and say, launch live. It's in the cloud. There's no provisioning problem. 30 seconds later, the attendees can go on there and use that module to leave feedback. So they have a very modular system, and it makes takes great advantage of the cloud. And the last use case that I have, which is really, I find really fascinating. It's amazing how you, as our application partners and customers, come up with some really unique concepts and ideas. So this is one of them. So this is from PCS, Press Computer Systems, a company in the UK. And they came up with this application called Social Knowledge. And the idea about social knowledge was, how about we try to understand what people are saying or feeling? It's about sentiment analysis, saying or feeling about some particular thing. So you identify a particular thing that you're interested in, and then social knowledge will go off using the I know technology and our data platform, which requires all of the capturing and analysis and sharing and everything else. The social knowledge will go off and take live input from all of the various social media feeds that are out there and do the sentiment analysis on the social media feed and narrow everything down specific to the concepts that you're interested in. this is a great example of sort of a breakthrough application, not only on our data platform, but a breakthrough application which is offered as software as a service. Because who are their targets? Who's the target for Press Computer Systems for this application? Their targets are companies like Nike, companies like General Electric, Toyota, Nissan, Honda. All of these companies who may want to understand how a particular campaign that they have, or how some news about some executive at their company who maybe got hurt. How is that news affecting the sentiment of the public? How is it impacting their brand? Those are the sort of clients that they have. But they're not only going after the big clients. They're also trying to go after some of the smaller clients. So you can imagine the scale difference that's needed in terms of the clients that they're going after. And software as a service with the cloud deployment model gives them the ability and the flexibility to do that. They didn't have to go out and purchase all of this hardware to host their systems by any means. So their whole thing is around listening, understanding, and engaging. Listen, as in you capture all the data and you capture it all, understand it, do some analysis on it, and then engage. And engaging is essentially saying, okay, how can I make value out of this thing? How do I understand how the public feels about this particular feature or this particular news, etc. Thank you for attending, and enjoy the rest of your day.